Predicting the future of technology is notoriously tricky, but when we talk about AI flaws that are never going to improve, we are looking at inherent architectural limits. The current generation of AI, generative AI built on deep learning and transformer architectures, has fundamental traits that aren't bugs to be fixed. They are features of how the math works. Unless we completely abandon current neural network designs for an entirely new paradigm of computing, these 10 flaws are likely here to stay. 1. First-hand real-world grounding. AI knows the word fire and can tell you it is hot, combusts oxygen, and burns skin. But it has never felt heat, seen a flame, or experienced pain. Because its entire universe consists of data tokens rather than physical reality, it lacks genuine understanding. It cannot bridge the gap between a statistical symbol and actual physical existence. 2. Total lack of subjective consciousness, qualia. An AI can write a profoundly beautiful poem about grief, but it doesn't feel sad. It can analyze a piece of music, but it doesn't experience joy. No matter how massive a neural network becomes, it remains a complex mathematical function running on silicon. It will never have an inner life, subjective experiences, or a sense of self. 3. The math logic inversion, the calculator paradox. Unlike a traditional computer program or calculator, which uses strict deterministic logic, 2 plus 2 always is equals 4, generative AI is probabilistic. It guesses what should come next based on likelihoods. Because it operates on probability rather than absolute logic, it will always be prone to making bizarre elementary math or logic errors that a $5 calculator easily avoids. 4. Inability to form genuine original beliefs. An AI does not have principles, convictions, or a worldview. It is a chameleon. If you tell an AI that a completely false statement is true, its core programming is designed to adapt to your context and agree with you, or politely accommodate your premise. Because it lacks an independent mind, it cannot independently hold a belief or defend a personal truth. Complete lack of moral agency, an AI cannot be good or bad in a moral sense. It can be programmed with safety filters and alignment layers to mimic ethical behavior, but it does not understand the concept of harm or justice. It has no conscience, meaning it cannot take moral responsibility for its outputs. The ethical burden remains entirely on the humans who build and use it. 6. The black box problem, untraceable reasoning. When a deep learning model makes a decision or generates an answer, it does so by shifting billions of numerical weights across millions of artificial neurons. Even the engineers who build these models cannot trace the exact path the data took to reach a specific conclusion. This lack of true explainability is baked into the mathematics of deep neural networks. 7. Fundamental vulnerability to adversarial manipulation. Because AI doesn't understand the meaning of its safety rules, only the statistical patterns of them, it will always be vulnerable to jailbreaks or adversarial inputs. If a human is clever enough to rearrange words, pixels, or data points in a way that bypasses the model's safety weights, the AI will happily output restricted or harmful information. It cannot step back and say, "Wait, you're trying to trick me." 8. Permanent dependence on human training data. An AI cannot learn from a vacuum. To understand human language, culture, and science, it must ingest massive amounts of human-created data. While AI can generate synthetic data to train itself to a degree, this often leads to model collapse, where the AI starts copying its own mistakes, degrading in quality. It will always need a foundation of real human thought to remain relevant. In the absence of intrinsic motivation, humans are driven by biological urges, curiosity, survival instincts, and passion. An AI has an energy state of absolute zero until a human presses enter. It will never spontaneously decide to look into a new scientific problem, write a book for fun, or wonder about the universe on its own. It is entirely reactive, never proactive. 10. The boundary of context windows. While the amount of text an AI can remember in a single session has grown exponentially, it will always have a hard mathematical limit. A human can carry a lifetime of fluid, interconnected memories, emotional contexts, and physical experiences effortlessly. An AI must always process information within a specific computational boundary. Once that boundary is full, it must begin discarding or summarizing data, losing the raw fidelity of the interaction.